Connection and protection of the power system is the topic of our today's presentation. The group members include Abdul Arham Khan, Abdul Rauf, Hasnain Arshad, and Talha Badr. As we all know that electricity is the basic need of mankind today. The electricity we use today does not come directly from the point it is produced. It passes through various stages before reaching our homes. From dams, it reaches the stepped up transformer to be stepped up so that I square R losses are reduced, as we all know that when voltage is high, the current level gets low. Then it's transferred throughout the country via transmission lines, which are high voltage transmission lines. Then, before reaching our homes, it is stepped down by the step down transformers, and through the distribution system, it reaches our homes for utilization and illuminates our houses. There are different connection schemes for the distribution system, which are followed. The types mainly include high voltage distribution system, in which radial system, closed loop system, open loop system, double supply system, grid form of high voltage system, and improved radial system are included. Substation and distribution transformer. It is made up of circuits called primary feeders or distribution feeders. This is the schematic of a primary distribution system. Let's talk about the radial system. In this system, all section and branches of a feeder are fed from a single source in a fixed direction. Here is a generator and the different loads are being served by a single source in a fixed direction. And here is the schematic of a radial system, which clarifies all the concepts about this system. Now, what is a closed loop system? If a high tension line emanating from a grid station covering the load area in shape of a loop finishes at the same grid station, returning to the same breaker or another independent breaker, it is called a closed loop system, and the system thus formed is a closed loop system. In this system, each transformer has two sectionalizers, one on either side of the transformer's tap points. This is a typical VAPDA closed loop system, which contains the bus bar, the station circuit breakers, the transformers, the sectionalizer switches, which are closed in case of closed loop system and make it open whenever open loop system is considered. Now, the basic difference between an open loop distribution system and a closed loop distribution system is created by the sectionalizing switches, which may open or close as per the requirement. Here are the sectionalizing switches which are being shown open, and this is the sectionalizing switch which is open, and this is the sectionalizing switch which gets closed. We may turn the open loop system into a closed loop system by turning all the sectionalizing switches as closed. Now, as we all know that the protection of power system is a vital and most important thing as far as the distribution and utilization is concerned. As the power system is constituted of various valuable devices, it is necessary that we should take certain measures to ensure life and finance safety. The power system protection basically includes transformer protection and line protection. Line protection is being talked about first. Circuit breakers are commanded by relays when extra current or voltage is detected to cut off the power supply, whereas the protective relays are used for automatic shutdown of the system via circuit breakers. It receives information through the current and voltage transformers, which are generally called CT and PT. Basically, what we have learned is that circuit breakers are generally controlled by the relays. So relays are the detecting devices, whereas circuit breakers are the devices used to cut off the power supply. Protective relays is defined as an apparatus designed to calculate the operating conditions on an electric circuit and trip the circuit whenever a fault is detected. So basically the relay purpose is to isolate current controlling circuit from the current controlled circuit and to control high voltage system with low voltage, and similarly the high current system with low current. The relays are also responsible for performing the logical function. This is the basic form in which the relay starts working. It first takes the inputs, measures it, determine whether a fault is done or not, and then outputs to the system whether or not to break the circuit. This diagram shows the working operation of the relay. This is how an arc breaks circuit, and this is the redundancy technique in order to increase the reliability of the system. And this is the seal-in arrangement, which includes the manual switch, the auxiliary switch, and the backup trip coil. Let's talk about the circuit breakers now. Circuit breakers are one of the vital and most important equipment in case of a protection system. Circuit breakers are used everywhere from houses to the power stations. They are one of the most important protecting device. They are used for breaking the flow of current. The medium which is used for breaking the arc basically includes bulk oil, air blast, vacuum, and sulfur hexafluoride SF6. Now grounding, which is one of the most important concepts in case of electrical protection. Why is grounding required? It is required by the electrical codes, by the equipment manufacturers. It is necessary for the protection of a personnel as well as high cost equipment. Type of grounding methods include electrical safety ground, lightning grounds, radio frequency shielding and grounding, as well as electrostatic grounds. Grounding, as defined by NEC, grounding means a phenomenon in which equipment or electrical device is intentionally or accidentally connected to ground or a conducting body that serves as a ground. Whereas what does ground mean is earth or something that serves in its place and is assigned a zero potential. There is a typical circuit in order to elaborate the importance of grounding technique. The current flows from transformer to service, through the overcurrent device to our load, through the load returning to the service, and back to the transformer. The overcurrent device protects the circuit from both overloading and short circuit. What happens if the load conductor comes in contact with metal box? Because transformer we are looking at is not grounded, so there is no path through the earth for the current to return to the transformer. Now our friend in this situation is safe. Grounding our equipment provides a second path for the current. The first path is through our friend to the earth and back to the transformer, while the second path is through our metal equipment to earth and back to the transformer. We need to open a circuit 15 amperes breaker as quickly as possible, which requires 4 to 5 times the rating of the breaker. The voltage is 120 volts and we can estimate the value of current which shall flow through circuit. So our current device does not open and our friend gets fried. So that tells us how much important is grounding for protection of a person. Now lightning protection. Lightning arrestor is a device used on electrical power systems to protect the insulation and conductors of the system from being damaged. Moreover, poles and towers are grounded by means of grounding rods. If protection fails or is absent, lightning strikes the electrical skies, thousands of kilovolts, flows through the transmission lines and can cause a severe damage to the transformers. If few conductors are affected by lightning stroke, then there will be phase to phase and phase to ground faults. Now let's talk about transformers and their safety. Three-phase transformers range from 3 kilovolt amperes to 500 megavolt amperes. In case of three-phase transformers, primary, secondary and tertiary windings all are wounded on the same core. Sometimes transformers are not provided with the circuit breakers, so other protection measures are to be taken. The protection schemes depend upon the size, importance, installation and cost effectiveness. Importance and installation are closely related things, as it is quite a vital thing to know where on the location is the transformer being installed, as this transformer is the most precious and valuable thing in the power system, and its price ranges to millions. Transformer faults are internal faults, pure differential protection, through faults, and ground faults. Now let's have a look what happens if transformer protection measurements are not taken. These transformer windings are damaged by excessive through fault current. Transformer protection measures ensure following advantages. It compensates the phase shift, causes phasing, and careful connection of the current transfers. Transformer protection for through faults includes high voltage fuse, tripping time, auto reclosers, and circuit breakers. Ground fault protection constitutes ground differential relay over current ground relay, directional over current relay connected differential. That's all for the protection and connection of the power system. I hope you liked the presentation. Thank you very much.